Good morning, everybody. We are looking at 6G Part 4 today, which includes piecewise graphs. Now, this should be revision for most of you from Unit 1. The idea of a piecewise graph, it is a number of graphs that are assembled and plotted so that they connect as one continuous graph. So what I've got here on my CAS behind me is an example of a piecewise graph. All right. If you notice the way that it's formatted, I have one part of the equation at the top here that goes between 0 to x to 2. And then from there, I have another graph that then goes from 2 beyond to everything else. And one of the benefits of doing that is when I press the trace button and I move along the trace, is it allows me to pass over the graph in one continuous piece. And this might be useful because if we're plotting out a particular model for a linear relationship, that linear relationship might not be true for all the values that we're using. So for example, if you were to plot a train accelerating at a constant rate, reaching a certain point and then decelerating at a constant rate, you could create a single equation that might model that situation, such as the one I've got here. All right, so this is the train's speed constantly going up, slamming the brakes, and then it slows down to a complete stop at this point here. All right, so one of the things that we have to think about is when we're asked to find particular values, that when we substitute them into the equations, we are substituting them into the correct equation. Now, in the case of linear model for piecewise graphs, they will join up nice and neatly like this. But sometimes what you might find is, for example, if I use a different set of values, I'll change this to a 4, for example, and I draw it, there's all of a sudden a gap or a drop. All right. In the case of these linear models, these graphs will always connect with each other. All right, so it slowly goes up, hits a certain point, and then continues down. And so if I was to ask you, well, what is the value of using this piecewise relationship, what is the value when x is 1? Well, when x is 1, if I look at the values that my graph cares about, 1 implies that it's in this space here, between 0 and 2. Therefore, I need to substitute 1 into this equation, not this equation, because this line doesn't exist at x equals 1. This is the line that exists. So it's all about picking and choosing which values make sense. So one of the things you need to remember how to do is to actually get it up on your CAS. So I obviously can't show you using my software here. However, I can describe it for you. What you are looking for is on your keyboard, under Math 3, you are looking for the icon that is in row 3, column 4. It looks like that. And if you press again and again and again, you can add more and more pieces to your graph. All right, but for right now, we just want 2 pieces. So what we're going to do is we're going to model an empty water tank being filled from a mountain spring. For the first 30 minutes, we have an equation of 15t. So it's 15 liters per minute. So it is going at a constant rate of 15t. In this case, we're going to be using x. And that's for the first 30 minutes, which means that we are going to need to use 0. And under Math 3, you can find the greater than equal to symbols, which you'll need to be able to do this sort of stuff. And then from here, we now need to put in the second piece. After 30 minutes, the flow slows down and it has a new equation. All right. Now, what you need to make sure that you do is when you're putting this in, you aren't just always using the greater than or equal to symbol, because it might confuse the CAS. In this case, what I've done here is, because these graphs overlap, it doesn't really change much, but you need to make sure that the value of 30 is included in one of your graphs and is not included in the other, because the graph, it can't exist on two graphs at the same time. So if I put that in, I'm going to draw that, and of course my it's obviously not going to fit. So what I need to do is I need to change my window. I'm going to change my x min to -1, my x max to 100, because the graph goes all the way to 100, and then I need to change my, well, I'm not going to have a y minimum, and my y maximum, let's conservatively say 1200. Oh, would you look at that? All right, so I'm just going to zoom out one more time, and you can see here the graph goes up at a particular rate and then hits 30 and then slows down and then continues to 100 here. So, and again, if we press the trace button here, we can follow along the graph, and it is one continuous piece. Well, it's one continuous line, no breaks. Everything is nice and smooth until you get to 100, in which case the graph becomes undefined and stops existing. However, at exactly 100, the graph exists and it's 1150. All right, so the questions that you are then asked about it is, using the appropriate equation, determine the volume of water after 20 minutes. So 20 minutes, is that in the top one or the bottom one? 20 minutes, which equation are you going to use? Well, because 20 is less than 30, you are going to use the top equation here. So, I mean, I can just go into here and I can actually just straight up type in 20 minutes, and it'll tell me the volume is 300. Where it gets a little bit tricky is when you get to 30 minutes. 30 minutes exists in one, not the other, but because they overlap, it won't make a difference. The value is still going to be the same, regardless of which graph you use, and that's going to be, well, let's just straight up do it. So value of 30, it's at 450. Now for the other two parts of that equation though, it says 60 and 100, which means that I now need to be doing my calculations using the bottom one. So when you are solving these and you are showing your working out, because you will be asked to show your working out for these sort of things, you need to make sure that you are stating the correct equation or the correct part or piece of the equation so that you can then continue on from there. So 60 minutes, obviously we're going to be using the second equation, and then at 100 minutes, we're going to still be using the second equation. All right. And then 1b says, use equations to construct a piecewise linear graph for 0 to 100. Oh, I think I've just done that for you. All right, so there's question 2 there as well, plus there are some other further example questions in the chapter review.